Hey, how's it going? In this video, I'm going to quickly walk through some code in a blog post I wrote with some examples on deploying the model Qwen image edit. And we're going to be deploying it on Modal. Um, at the beginning of this blog post, I have some links here where you can go read about this new model, Qwen image edit. It's based on Qwen image, and then like with this Qwen image edit model, you can take an input image and a text prompt and then modify that image to create a new one. So it's really good for image editing. And on this blog post, they have lots of good examples. So they have the input image here, and then they just provide the prompt, obtain the front view, and it creates this image. Um, or this input image here, obtain the left side, and then the image looks like this. So it's really good at like keeping character consistency and things about the image. Or you can like change the image to be animated or so on. It's really good with text. Here they add like a sign to this one with penguins. We'll be testing that one out. Here they remove like a piece of hair and so on. So it's really, yeah, like I said, it's really good at adding text to the image and changing just parts of the image and leaving other parts of the image the same. So very powerful, very exciting. They had an announcement on X here. The Hugging Face model card is really good because it gives you how to install. You can run it through the diffusers library from Hugging Face, and this is the inference code right here to run it on a GPU. And what else? Oh yeah, they have like their GitHub repo and so on. So we're going to be basically just taking this inference code right here and deploying it to Modal, and we're going to create an endpoint so that we can pass in image URLs and a text prompt and some other parameters and then generate the image. Okay, so the first thing you should do is head over to modal.com and install it and add it to your environment. Modal usually gives they do give like $30 of free credit a month. So you can just sign up at this account, modal.com website, and you can run pip install modal to install it in your environment, and then you just type modal setup to authenticate. It's really easy. I encourage you to go read the Modal docs. They're pretty awesome. So once you set up Modal, we are going to create two different files. So one is going to be called Qwen image edit.py, and this is the code right here. It basically creates an image container with all the dependencies you need. We use some volumes for storing the model weights and the generated images. And yeah, this is just the code right here, the inference code. And then we deploy a fast API endpoint. And then there's also a fast version, which is available, which you can run through Qwen image lightning. So this is the exact same code as the code above, just using this fast lightning model, and it allows you to use like 8 inference steps, and the inference is just faster. I got this idea from this repo right here. Actually, this Hugging Face Spaces from Multimodal Art. And then when you look at the code here, they had some code where they were running the inference with this lightning model. Yeah, Qwen image lightning. And you have to configure this scheduler and so on. It's just like a few different code changes. And so that's what this second file is. I'd call it Qwen image edit underscore fast.py. And it's the same code as the other file, just with a few differences. I can actually show you the differences. So if I just copy this here, I have the two files here, the regular version and the fast version. We can compare the text with the clipboard, and the only difference is the part highlighted in green over here. So importing math, adding one extra library here, changing the name of the app, the scheduler config that's required for running this lightning model, these LoRa weights that we are adding in, and so on. So just a few different differences about the model. The number of inference steps by default is 8 instead of say 50. And those are the changes, the only changes. And then there's a different endpoint. This endpoint is hard coded to the one that I get when I deploy, but your endpoint will be different. Okay, so once you just copy and paste this code into these files, you have two different files, Qwen image edit.py and Qwen image edit fast.py. I have an environment here with UV that I've already added Modal to, and I've already authenticated with Modal by running Modal setup. But to deploy the endpoints, you can just do UV run Modal deploy and then the name of the file. So we're going to have this Qwen image edit.py. So now it's deployed, and we're also going to deploy the other one. The very first time you run this, it'll take longer because it has to build the container, but everything here is already cached, so the container startups or deploying it's very quickly. So now those two applications are deployed. I can go over to Modal now and go to my dashboard and see that I have those two applications deployed. To start up the container, you actually need to send a request. So right now, if I go here, there'll be no containers running. And same for the other one, the fast version. There's no containers running. It's just waiting for the first request to come in. So I could send a request to the endpoint, or I could just like click on this URL right here. So that's one way of sending a request, not for image generation, but just trying to access the URL of the endpoint. And if I go to the fast one, I can also click on that URL there too. So I have these two URLs, those two endpoints that are loading right now. And we can see that they're cold starting. Okay, and the cold start usually takes between a minute and a minute or 2 minutes. So there are the checkpoints being loaded right there, the model waits. They've already been like downloaded to a volume. So in both these files, I have this Hugging Face hub cache object, a modal.volume. And basically what that does is it mounts this volume, and so the model weights are stored there. So like when I run the next build of this container, instead of fetching the weights over the network from say like Hugging Face, they can just be fetched from the volume storage. So that's the point of the volume here. And I have another volume for adding the saved images to save them. Okay, you can go through the code here if you want. There's just some modal decorators, so then like some just regular Python code and Hugging Face like inference code that I got off the Hugging Face inference model card. And the main point is that we give it an endpoint right here, and it can take in an image URL, a prompt, a negative prompt, the true CFG scale, a random seed, and the number of inference steps. And for the fast model, it's the exact same interface. Just by default, it has 8 inference steps. Okay, and I have some code here to test the model at the bottom, which just imports, which you can just run in your IPython or whatever. It imports the request library. You have your URL that you want to hit, and then some different test cases. So it has the input URL and a prompt to edit that image. So we can try running this in IPython here. And I'll open up another terminal here to run the fast version. And we can see if those containers are started yet. So this container is up and running because it says live. And the editor fast, the container's live as well. Okay, so we can run this right here. Maybe we'll change the inference steps here to 40 for this one. And then, so that'll go to that container. And then the other one, the default inference steps is 8. So we can hit the endpoint like this. Okay, so the images have been generated on the first model. This is the original one without the, not the fast version. So you can see on like an H100, the inference was taking around 47 seconds or 40 seconds. Yeah, 45, 48 seconds per image. I'm sure there's some ways to improve that, but we can look at some of the results. So here's the image URL, the original one. And then the prompt was add a small wooden sign in the foreground in front of the penguins with the text, "Welcome to Penguin Beach." and here is the generated one. So if we flip back and forth between those, I'll just do that a couple times. So you can see like it's changing a little bit of the contrast of the image, but like it's not bad still. And then it adds this nice little sign, welcome to Penguin Beach. The next one is this input image here. And then we say change the girl's hair to blonde. So there's the image. So if we flip back and forth between those, see like the zoom changes a little bit. I think unless I'm zoomed in more, let's zoom out a bit. 110%. Yeah, so if we switch back and forth between those, I mean, it's really good. It's just changing the hair color. This next one removes a fork from the image. Yeah, so there's me flipping back and forth between the images. You can see like the menu is basically unchanged and it's just removing that fork. The food on the plate looks exact. This one is trickier. I ask it to change the price of the menu item, kinesis or whatever this is called, to $20. This is the item right here. It's 45 on the original image. And you can see it kind of changed it to 20 on the second one. I mean, that's pretty amazing that you can say that and just edit that one little part of the image. Okay, so those are some examples with the larger model. With the fast model, I'll just show a few examples. These are the same prompts. I'll just close these. So image URL. So this is the fast one. I noticed the hair doesn't look quite as good, but still it's decent. Oh yeah, and for the fast model, like the inference with 8 inference steps was around 11 or 12 seconds. So like much faster. This is the one removing the fork. So you can see here it changes a bit more of the menu color, but still like decent. And then the last one, changing it to $20, like you can notice it changes a lot of the menu items to $20 with the fast model. So I think for really detailed edits, the larger one's better, but for simpler edits, I'm sure the fast one is great. Okay, and then like, yeah, that's basically it. I have some other examples in the blog post here. Here was the input image. And I'm mostly running the fast URL in these blog post ones, but here it says transform this image into Ghibli style. Change the color of the purse to the same color of the jacket. That's the original model, but here only with 10 inference steps instead of say like 40 or 50. This is the faster model with that same prompt. Change the color of the hair to blonde. I already showed you this one. Yeah. This is one with the dog face to the right. So that's the input and the output looks like that. Change the color of the door to yellow. This one works really well. Turn the dog around. This one doesn't look as good. You can see there's definitely some AI artifacts in there. That was with the fast endpoint. Maybe the slower one would be better. Change the dog to sitting. That's decent. This is one off of the Qwen blog, I think. I forget where I saw it anyway. Restore the old photograph, remove scratches, reduce noise, enhance details, and so on and so on. So that's the input image, and the output image looks like that. Here's just an image of in Nova Scotia, the province where I live in Canada. Just like some ocean water, a little fishing village or fishing shack here. So I said add a sunset to this image. It looks a bit unnatural, but still quite decent. Like the way the water looks and everything, I think it's really good, impressive. Add a fishing boat to the image. So there's the input and the output. This one looks more AI generated. Especially the next one, add a pod of killer whales swimming out of the cove. It just looks really cartoonish. I think you'd have to play around with this to make it look actually good. Okay, so that's the blog post, and all the code is there. I'll add this video to this blog post, and I will add all the links and everything to the blog post as well as the YouTube video. Okay? All right, thanks very much.